Right, so in this video, we're looking at implicit differentiation. So we're going to be differentiating, finding dy dx. So what that means is that whenever we encounter our y terms and we differentiate, we're going to attach to it the dy dx, all right? So that's the only difference. We're going to be doing normal differentiation, except for when we have the y terms, we're going to attach dy dx after we differentiate it. So let us keep going. So what we're basically doing, we're going to differentiate the entire thing, right, with respect to x. So we're going to be trying to find, we're going to try to find the dy dx. And let us put this on. So here we're going to start with that first part. So 3 to 6. So we have 6. We have 6x raised to the second. Okay. And that is going to equal to, we're going to differentiate this part. So we're going to actually have 4 y. And because this is a y, we're going to have to attach to it dy dx, right? And then the differential of a constant is 0. So this is what we have. So in this case, in order to isolate our dy dx, because this is the key to isolate that, we're going to divide both sides by 4y. So as you could see right there. Now we have the dy dx, which is isolated. Also, we're noticing that we could reduce this because if we divide the 6 and the 4 by 2, we're actually going to have a 3 over 2 there. So finally, we could say that dy dx is equal to 3x squared over 2y. There we go. So that's our first example right there. Let us take a look at the second example. All right, so in example 2, we're doing the same thing. We're going to differentiate everything with respect to x. So we're trying to find dy dx at the end of the day. So let us get into it. For this part, we have 3 2's, and this is going to be 6x, and it's raised to the first power right there. And then when we differentiate this, we're going to get 6y. Because we differentiated the y, we're going to attach. And when we say attach, I mean multiply dy dx to it. And then it's equal to 0 because the differential of a constant is a 0. So what we want to do here is, in an effort to isolate the dy dx, we're going to have to move step by step. So we're going to get this on the other side, okay? So let's rewrite this. So what we have is a 6y dy dx, and this is equal to negative 6x. What it means is that we actually just subtract 6x from both sides, or if you want to say you move it across and change the sign, then that's okay. Finally, we're going to divide both sides by 6y so that this could have canceled into itself. That's one time. So we're going to divide this by 6y as well. As you could see, our dy dx is now isolated. On my left side, I see where I could cancel stuff. For example, 6 into itself one time. So dy dx is actually negative x over y. And that's good for our second question there. So let us take a look at the third question. So for question 3, we have in a similar situation. We're taking the derivative with respect to x, and we're isolating dy dx at the end of the day. So let's go. When we differentiate this, we're going to get 5 2's 10, 10y. But because there's a y in this, we have to multiply everything by dy dx right there. And this is equal to 6x squared minus 5 again, because the differential of negative 5y is just negative 5. And so we're going to have to multiply that by dy dx. Now, what I want to do is to collect all my dy dx one place. So I'm going to migrate the negative 5 dy dx to the left side. So let me rewrite to see what we have. So we have 10y dy dx, and then we're going to have positive, because the negative 5 would be a positive 5 dy dx here. And this is equal to 6x to the second power. Now, at this time, what I can do is I could factor out dy dx, right? So if I factor out dy dx, I'm really left with a 10y plus 5, and this is equal to 6x squared. Now, at this moment, I definitely can divide both sides by 10y plus 5. So I'm going to divide this by 10y plus 5. So on the right side, it cancels itself. So finally, the response is that dy dx, let me fix this. So dy dx is actually equal to 6x squared over 10y plus 5. Right? So there that is. That's our third example. Let us take a look at the fourth question here. All right. So we're doing the same thing. We're taking the derivative of this with respect to x. And in the end, we're going to isolate dy dx. Okay. So let's get it. So 4 2's, this is going to give us 8x. And this is equal to 6y to the second. And then we're going to attach dy dx to that plus 4. Because it's a y term again, we're going to have to attach dy dx. Now, the fact that I have dy dx on the right side, what I'm going to do is I'm going to isolate it, which means I'm going to factor out dy dx. So let us factor out our dy dx here. So in parentheses, I'm going to have a 6y squared plus 4. And we're almost done because in order to get the dy dx by itself, I have to divide both sides by 6y squared plus 4. So on the right side, you're seeing it cancels itself, but it's going to show up on the left side. So 6y squared plus 4, right? So what's the final response? The final response is that dy dx is equal to 8x over 6y squared plus 4. Now, if we want to factor out 2 here, like for example, this is 8x, and if we want to factor out 2 at the bottom, we would have 3y squared plus 2, and then this 2 could cancel into the 8, 4. So the final response could have been 4x over 3y squared plus 2. So this could be the simplified version of our dy dx. Let us look on the last question, right? So question 5 right here. So for question 5, we're doing the same thing. We're taking the derivative of the entire thing with respect to x, and then we're going to try to isolate our dy dx as we go along. Now let us see what we got right here. So in this question here, we have 3, 5. It's going to be 15. So I'm having 15x raised to the second power. And this is actually equal to, but this part, we're going to have to isolate these, okay? So because we have x and y multiplying right there, we're going to have to apply the product rule. So what that means, I'm going to take the differential of the first piece, which is the negative 3x. It's going to be negative 3. And then I'm going to write back the y. Plus, I'm going to take the derivative of the y. So basically, it's going to be 1 dy dx. And then I'm going to write back my negative 3x right there, right? So that's what we have right there. Now, when you take the derivative of this constant, it becomes a 0, so we're good. So now let us start putting this together. The first thing I want to do is to migrate this to the left side. So I'm going to have a 15x squared, and this is going to be migrated. So basically, I'm going to add it to both sides. So it's going to be positive 3y on this side, and this is equal to dy dx times negative 3x. Now remember, in an effort to get dy dx by itself, I'm going to divide by negative 3x, and you could see what's going on here, negative 3x, right? So we have dy dx isolated, but I could factor out 3 at my numerator. So basically, let me factor that out. I'm going to have 3. Let me factor this out quickly. So I'm going to factor out 3 at the numerator. So it's 3, and then I'm going to have a 5x squared plus y all over negative 3x. Now you could see that this could cancel. So negative 3 cancels itself, and up here, this is a negative 1 I'm using there. So I'm going to distribute that negative 1 inside, right? So this is equal to dy dx. So that negative is going to affect my numerator. So basically, I'm having negative 5x squared, and it's going to be a negative y because I'm distributing this negative inside. That same negative from the negative 3. And all of this now is over positive x. This is equal to dy dx. If you want to flip it around and write it like this, not a problem. Dy dx is equal to negative 5x to the second power minus y all over x. And there it is. Just a quick touch on implicit differentiation. See you next time. Very much concepts. Bye.